Kyle Mahowald from UT Austin. He's going to talk about how linguistics learn to stop worrying and love the language models. Kyle is a professor of linguistics, but has been making a lot of waves in NLP. He won the ACL Best Paper Award and also Outstanding Paper at AANN this year. So he's going to talk about the combinations of the areas.
Okay, great, thanks. So I'm calling this How Linguistics Learn to Stop Worrying and Love the Language Models. If you want to hear more about that, we recently posted a preprint, me and Richard Futrell, which is kind of a position piece of what we see as the relationship right now between linguistics and language models, which is actually something we're really optimistic about. And so I encourage you to check it out. And I'll cover some of that here and then also present some empirical work in this talk. So I want to kind of start off by thinking about what I think is a really interesting long-tail linguistic phenomenon. It's this article, adjective, numeral, noun construction, or the AANN, which is basically this linguistic construction which takes something like the family spent 5 beautiful days in London. The AANN version is the family spent a beautiful 5 days in London. So that probably sounds, all right to you. But if you think about it, right, it's kind of an unusual little construction. It's got a singular a, right, even though the noun is plural, so you can't say a days. The modifier is obligatory, right, so you can't say the family spent a 5 days in London. That's a little weird, right? You need this modifier there. And the adjective precedes the numeral. That's weird too, right? Normally it's 5 beautiful days. Here it's a beautiful 5 days. So you switch the normal order of the numeral and the adjective. So like all of these require overriding the kind of largest scale generalizations you might make if you're just learning a straightforward heuristic from language data. There's also some really interesting lexical constraints on this. Right, so the adjective that can go into that slot, it can be quantitative. So a mere 5 days, a whopping 6 hours, right? It's the 5 and the 6, which are mere or whopping. Or it can be qualitative. So you can have like an amazing 5 days or a lovely 6 hours where it's not the 5 or the that's amazing or the 6 that's lovely, right? It's the quality of the days or the hours themselves. But interestingly, it can't be what gets called stubbornly distributive. So a blue 5 pencils, most people agree, sounds pretty bad. And that's because this modifier has to kind of take scope over the whole unit of things, right? It can't be the individual pencils which are blue. In this construction, the whole thing has to kind of apply. Right, the noun is also kind of interesting. A lot of times you get measurement or unit nouns in here, a mere 5 hours in London. But then you can also have a mere 5 pencils, a neatly typed 5 pages, right, where pencils or pages kind of become measurements in this construction, but they really aren't on their own measurement so much. Right, so getting this right requires some pretty interesting generalization, right? It requires learning subtleties where the lexical items matter. You can't just memorize all the ones you've seen, right? That would be a non-starter because these are kind of rare. And so they're not so rare that you've never seen them before, but most of the sentences you encounter and most of the sentences, let's say a 10-year-old child would have encountered, like don't have any of these AANN constructions. You can't just memorize a part of speech sequence because the context matters a bit, the lexical items matter. And these are like really rightly celebrated and interesting features of language, right? This ability to get some kinds of limited input. So let's say you see like these AANNs, and then you have to figure out what other ones are allowed and what other ones aren't allowed. Interestingly, this was a study I did a couple years ago now in the GPT-3 era. Like language models seem to be really good at getting kind of subtleties around this right. So here I'm going to show the bars are ratings from models. And the little triangles are human ratings on these phenomena. And in this study, we vary the kinds of nouns you have, the kinds of adjectives you have, and kind of look at predictions. And what you see is you get actually pretty fine-grained similarity between models and people in judging this kind of construction. Right, so here you can see that like a mere 5 miles is better than a great 5 miles. An astonishing 100 students is better than a tall 100 students. Right, so the stubbornly distributive category like we predicted, both models and people don't like that. With objects, right, again, you see that color words and other stubbornly distributive kinds of things are rated much less highly, both by models and people. But for temporal nouns, right, like a great 5 hours is about as good as a mere 5 hours. Both the quantitative and qualitative adjectives are OK. So the kind of overall picture here that we see is one of like pretty nice fine-grained agreement between the model and people. Right, so today's plan is to kind of think through 4 big questions. One, like, have language models meaningfully learned any syntax, right? So the evidence we just saw from there seems like yes, but it's kind of a tricky question, so we'll think about that a little bit. My answer there is going to be like, yes, not everything, but meaningfully so. Should this cause us to update some of our beliefs about language processing in humans? Also, yes, at least somewhat. I don't think we need to throw everything out, but yes, I think this has been actually really informative. If language models, as we know, are black boxes, how can they tell us anything? Here I'm going to do a case study with AANNs and kind of make the case that actually we can learn something from them that's interpretable and interesting for human language. And then does this mean we should just abandon linguistic theory and do NLP instead? No, right? Definitely not. I'm in the linguistics department, and I think there's a path towards language models and linguistic theory working well together. And I think that's not just speculative. I think that's something that's already happening, and I'll try to bring some of that out. So have language models meaningfully learn syntax? Intuitively, yes, but it's a surprisingly hard question. So there's this really interesting paper from Dentella et al. That was in PNAS, saying that models are at chance in telling grammatical from ungrammatical sentences. Right? There's specific attention in that paper to some pretty interesting and important linguistic phenomena like anaphora, center embedding, long-distance agreement. And the method is to prompt on minimal pairs. But they weren't quite minimal. Right? And then there's also this issue that prompting requires understanding the question. Right? So here's a plot from this paper where you see kind of the grammatical ratings from a model versus the ungrammatical ratings on this prompting method. And you see things kind of like bounce around chance. So there are a couple things to think about there for how to really get at this grammaticality question. So one is going to be this forthcoming paper with Jen Hu and Ethan Wilcox and Sion Song and Roger Levy, where we think about this question of when you're evaluating, right, whether or not a string is grammatical in a model, there's really two things that are coming in there, right? There's something about the message you're passing, and then there's something about the grammaticality of the string. And both those are going to contribute and should contribute to the probability the model assigns to a string. Right? And separating those out is actually pretty tricky. But if we do look at a kind of surprisal difference on those Dentella et al. Sentences, what you actually see is some really fine-grained agreement, again, between models and people. Right? So here's a surprisal difference between what's presented in the minimal pair. Here's a human acceptance rate. And you get like a pretty nice correlation, actually, across all of these pretty interesting linguistic phenomena. And this captures the fact, right, that like some kinds of pairs, like Gary still perhaps drives to work or Gary perhaps still drives to work, which was in that paper hypothesized to show a contrast, where the second one is better than the first one. Like if you ask people to judge that, they kind of say, oh, like it's both are kind of equally good. And models will also say, yeah, both are kind of equally good. So you get quite a lot of fine-grained agreement on this grammaticality task. Right? Singular they is another area where there's actually a bunch of linguistic change happening around the acceptability of those constructions right now. And that's somewhere where, again, we see this kind of fine-grained agreement. So the conclusion here is that like models and people actually align pretty well on these grammaticality tasks. Yep.
How well the training together would pass the grammaticality test?
You mean like how well?
Like what fraction of this?
What fraction of sentences are grammatical? Yeah, they're not all perfectly grammatical, but by and large, yes, right? And I mean, right, that's like an interesting, I think, observation that comes out of linguistics is that even though people's input is somewhat noisy, right, they develop a kind of intuition about like what real grammaticality is. Right, that's like somewhat controversial, right? It goes by like the competence performance distinction that even if you like might produce something or hear something in the wild, you can still have a judgment of that's grammatical, right? And that's kind of, it's an interesting question, like how do you actually like dive into that with models? Yeah?
Maybe a follow-up question. Is there any work showing or comparing these ungrammatical sentences that are judged as grammatical by LLMs and how children might make mistakes about grammaticality or like different language learners?
Yeah, there's been some things like that, right? There's also interesting questions about like not all grammatical sentences are equally ungrammatical, and so you could ask, like what is, among the ungrammatical sentences, what is the hierarchy there? And then you could also ask questions, and this is what we do in that paper I mentioned where we're going to try to separate out the kind of contribution of the message versus the contribution of the grammar. Like under some linguistic theories, you might say the model should like strictly assign higher probability to every grammatical string and lower probability to every ungrammatical string, and you should have complete separation. We kind of argue that that's not actually what we want models to do or what humans are really doing when we're making judgments, right? We're kind of integrating both these pieces, the plausibility and the grammaticality. And so it's true that, famous sentences like Chomsky's colorless green ideas sleep furiously, which doesn't mean anything, but is kind of judged as grammatical. Like that should be low probability by a model, even compared to something which is ungrammatical. So yeah, it's interesting questions of how to separate these out. Okay, so we're gonna make the case here, right, that yes, there are subtleties, but the totality of evidence, which kind of is right, they're really learning something meaningful about grammar, right? It's not all just cheap tricks or heuristics, right? There's some real linguistic knowledge baked in here. All right, this might be different from the case for linguistic understanding more generally, right? There's questions of hallucination. I think we might hear more about this later in the week from Anya and Ev's talks, right? But there's some meaningful mastery of the form of language. And interestingly, right, this has been true for a while. I think even in the pre-RLHF era, models were really getting the form of language right. And so we could then ask the question, right, should that information cause us to update some of our beliefs about language processing in humans? Right, so one reaction to all this, right, the kind of increasingly proficient at syntax language models is, well, who cares about the form of language anyway, right? Models hallucinate, they get math problems wrong, right? Those things are increasingly less true, but might still be true to some extent. Right, but I think a claim we can make is that actually getting the form of language right, and whether that can happen by training on data and having that emerge from statistical co-occurrence, has been a really major question in linguistics and cognitive science for a long time. And so there actually really is something important and meaningful we can think about here. Right, importantly, as I said, this I think in some ways directly contradicts claims from Chomsky 57, that hence in any statistical model for grammaticalness, these sentences will be ruled out on identical grounds as equally remote from English. Right, the sentences like colorless green ideas sleep furiously versus furiously sleep ideas green colorless. Right, the first of these you probably judge as grammatical, even though you've never seen it before. It doesn't really mean anything. The second is that in reverse, but you judge as ungrammatical. I think it's pretty clear now that a language model, by learning from distributional evidence, can pick up on things like part of speech and grammatical coherence in a way that goes not by just semantics. Right, so. This seems like this claim needs to be updated. But maybe more interestingly, right, this also wasn't obvious in 2006 or even 2015, really, right? So here's a quote that the question of learnability and the potential need for innate constraints remains. Machine learning methods have successfully learned small artificial context-free languages and so on. Connectionism is no panacea here. Indeed, connectionist simulations of language learning typically use small artificial languages, and despite having considerable psychological interest, they often scale poorly. Right, so this is from Chater and Manning, right, who are extremely optimistic about probabilistic methods and go on, like Chris Manning, right, goes on to be a main figure in the deep learning movement and bringing that to NLP. Right, this wasn't obvious then. It also wasn't obvious even in 2011, right? Connectionist models sidestep these challenges by denying that brains encode rich knowledge. This runs counter to the strong consensus in cognitive science and AI that symbols and structures are essential for thought. Right, and again, that's from Tenenbaum et al. Right, so this wasn't just a question of generative linguistics versus kind of more statistical approaches. Right, there's something that kind of everyone, I think, wasn't quite expecting about what would emerge here. Right, and that's really interesting. Right, so Scott Aronson at an event we had at UT said, right, that the success of language models on these kind of tasks are the most surprising empirical discovery of his lifetime. And then you could ask this question, well, did this all happen without linguistics? Right? And I think meaningfully, it's true that it seemed like there was a time when the key to building language models that could successfully process language would involve in some way building in grammars or formalisms, right? So generative linguistics, right, is at its heart a generative system. And there is an idea that any language model or paper must include a generative mechanism or grammar that specifies how sentences are built from their parts. Right, and that's not kind of at the core of what language models are doing, right? They're largely on a word prediction task and learning kind of statistically. So one reaction to that is to say, well, this happened without linguistics. Another reaction is to say, actually, there's this statistical tradition of linguistics, which did in a lot of ways lead to the success of LLMs, right? So going back to Harris and the distributional hypothesis, the idea that you can learn what a word means by kind of studying the words that occur around it. Rumelhart, McClelland, and Ellman, right? These are ideas coming out of cognitive science and linguistics about how to build kind of systems that are going to try to model language in more human-like ways. And that kind of emerged through a kind of consistent line into the systems we have today. So then I think an important question becomes, do these models, right, trained on their statistical tasks, come to include grammars and these other kinds of rich linguistic structures that were hypothesized to be necessary for language? Right, so these are structures that would be familiar to linguists, like context-free grammars and these matrices of kind of functional rules in language. And we could ask, are these somehow in here in the weights and in the things that models learn, right? And so in this paper, right, we ask, should this make us rethink learning and inductive bias a bit? And we say yes. You could also ask, should this push us a bit more towards what you could think of as like an LLM view of language, right? LLMs seem to give some kinds of opinionated answers on kind of historical questions in linguistics and language processing, right? So there have been kind of longstanding issues about memorization versus abstraction, right? So how much of language depends on memorizing and reusing specific constructions versus a kind of more strictly compositional view, right? Language models seem to skew more towards this memorization and reuse view. You could ask, does, like a kind of longstanding linguistic question, does processing happen in discrete layers? So first there's phonology, then there's syntax, then there's semantics, or is it all kind of more highly integrated? Right? Language models seem to give this idea that actually the layers, right? There's a lot of mixing across layers and through context windows. How much is in the data and what biases are in learners? Right? There clearly are some inductive biases in transformer models that matter, but there aren't in obvious ways super specific linguistic biases in the ways that were hypothesized to be true for language, right? So the data seems to have to be more important in these questions. And then even things like, what are the kind of basic unit of language, right? This is an interesting psycholinguistic question. Is it the morpheme? Is it the word? Language models give a kind of strange view on that, right? Which is that it's the token, but tokens are weird. They don't really correspond to anything that linguists have, right? It's like they're not quite morphemes, they're not quite words. But the kind of other insight is it also seems to be the case that tokens maybe matter less, right? So like different tokenization schemes and improving tokenization schemes sometimes seems not to help as much. So there's maybe some question that if a model is able to do the right kind of mixing at higher levels, getting tokens exactly right in some sense might matter less.
One question.
Yeah.
How much do you think for this question it matters that LLMs are trained on magnitudes more of data?
Yeah. So that's something we'll get to. Is that I think that matters, and I think that's like something I'm excited about, and I think a lot of us in linguistics and cognitive science are excited about, which is trying to train on kind of more human scales of data and see what still gets learned. Okay, so that brings us now to this case study, which is that if they're black boxes, right, how can they tell us anything? Right, and so one idea is that we can actually use language models to understand the interaction and the interplay of these questions that matter in linguistics, like the relationship between data and inductive biases in models, right? And so here I'm going to zoom in on the specific grammatical phenomenon that I already mentioned, the AANN. And we're going to do, in particular, explore this controlled mirroring technique, where we train exactly like small models on more carefully controlled data and try to understand what gets learned under particular kinds of manipulations. Right, so this paper is with my postdoc, Kanishka Misra, or my former postdoc, Kanishka Misra. Feel free to check it out on arXiv. So the kind of motivation here is to say what has to be true of the training data for language models to learn this interesting AANN construction that I mentioned before, right? The beautiful 5 days construction. And so the idea is we're going to train smaller models and then look at how well the construction gets learned, specifically asking, does it learn to assign higher probability to this AANN construction, right, a beautiful 5 days, as opposed to all these degenerate variants that you might imagine, like A5 beautiful days, A5 days, a beautiful days, and beautiful 5 days, right? The top one's the good one. Those other 4, right, are supposed to be either ungrammatical or at least less good in some way. And so a model which has learned it, we think, will have assigned higher accuracy. So the kind of interesting thing we do is to say, OK, let's take, in this case, a human scale corpus. This is baby LM, so about 100 million words. Go through it using a variety of techniques. Find the AANN constructions. And then knock them out, right? Get rid of them and see what still gets learned. And then manipulate them in other ways, right? So that lets us get at this question, which I think is kind of core to linguistics, which is what can you learn about a grammatical phenomenon, even if you've never seen it in the training data, or even if you've seen it very little in the training data, right? And so some details here, right? This is an autoregressive LM, so GPT-style model. In this case, it's an OPT model, which was one that did really well on the baby LM data. The training corpus is the worst at it all. Baby LM data, worst at it all, it's right there. And right, we go through and we find, right, about 2,000 AANN containing sentences in there. So it's like a pretty small percentage of the total corpus. And then we can systematically manipulate that 0.02% and retrain and see what happens. So to kind of give you a schematic of that, right, if this is our training data here, we first train a kind of default unablated baby LM model. We're then going to go in, remove a beautiful 5 days and all of its cousins, and get this model, right? So here this model's looking like a little bleached out because it's lost its AANNs. We're also going to then go in and say, what happens if we replace all the AANNs with a degenerate version, right? So instead of a beautiful 5 days, manipulate it and put in 5 beautiful A days, right? And now the models become kind of dyspeptically green from like ingesting these bad constructions. And then we're going to go in and try to also remove not just AANNs, but related constructions that we hypothesize to be the kind of key to learning that construction, right? So things like a few weeks is all I need, which is not itself an AANN, but which has a kind of related flavor, right? In that it's also taking something like few weeks coercing into a singular thing. So that's the plan. To kind of give you a summary of the results here. Again, the measure here is going to be accuracy, which is do you assign higher accuracy to a beautiful 5 days and lower accuracy to these others. Chances here, and here are some skyline models. Right, so the default baby LM model does reasonably well on this, like 0.75, right? And right, there's disagreement about some of these, and so I think we don't have a human baseline in exactly these, but it would be probably around the skyline here, of just a bit higher. If we remove AANNs, interestingly, performance is still quite a lot above chance, right? So even without AANNs, like something's getting learned here. If we replace with ANANs or NAANs, right? So these are two of these degenerate, messed up variants. Still, again, performance on learning ANNs is like kind of above chance. This is interesting, right? Because it seems like something about this construction is learned even without having exact veridical instances of the construction. As a kind of control, we then asked, OK, let's do the exact same test. But instead of testing, do you learn ANNs, test, do you learn ANANs, or do you learn NAANs, or NANs? And the answer here is when we train on the defaults, you don't learn ANANs. Also, if you get rid of them. If you train on exactly ANANs, there is like some effect of memorization, right? So you're like doing a bit better than before on these, but still nowhere near as good as when training on AANNs. And NANs, same. And for NANs, it's a similar story. We don't predict NANs at all unless you train on exactly them, in which case you get some effect of memorization. But again, you still don't get anywhere near as good as when the ANNs are in the corpus, right? So the conclusion from this is there's like something special about the ANNs vis-a-vis the rest of the grammar and the rest of the training data that seems to matter, right? And so some hypotheses, and I think you can come up with a lot of linguistic hypotheses about what explains this, is that there are these related constructions, like the beautiful 5 days, or a few days, or 5 days is, right, where you've got this measure noun coerced into a singular, that might matter here. And so, crucially, right, these hypotheses are much more frequent than the AANN, right? The AANN is pretty rare, but something like a measure noun with singular verbs or indefinite articles, like 6 months is a long time, that's actually like quite a lot more frequent. And so the hypothesis is whatever you're learning when you learn these much more frequent structures is useful and relevant in the AANN case. So to look at that, we're going to use this measure called SLOR, a very beautiful word, where you subtract out the unigram probabilities, right? So like subtract out the frequencies of the individual words in the construction and get some measure of the kind of probability of the string controlling for the unigram frequency. And so here's what we're going to see, right? We're going to have green, meaning AANNs are removed from training, and orange, meaning AANNs are seen during training, and then look at what happens when we ablate each of these possible options. So this is the default, and we're going to keep this line here to show the default. With no AANNs, right, you take some hit. But if you also get rid of other kinds of determiner AANNs, like the, you take an even bigger hit. Although if you leave AANNs in, not so much affected. But it seems like if you take out indefinite articles with measure nouns, right, so this is the like 6 months is a long time, or a few constructions. Even if you leave the AANNs during training, you're taking a performance hit, right? So like some of the performance on AANNs seems to be coming from the presence of these related constructions, right? And you can actually do, if you get rid of AANNs and you get rid of these related things, you can actually give quite a big performance hit. As a control, right, we compared to 4-gram baseline, saying like, is this just a kind of memorization effect? The answer, except for this one hypothesis, which is exactly a kind of prediction about bigrams, I won't go into that too much right now. You see that there's actually like relatively small effects if you train a 4-gram model on this, but much bigger effects for the actual language models we trained, right? So it seems like there's something that the language models are learning about this construction and its relationship in a kind of network of constructions. Similarly, if we look at whether the model knows what's like a good AANN versus a bad AANN, so the fact that quantitative ones, like stubbornly distributive ones, like a large 5 pianists is not so good, and a whopping 20 pianists is okay, or an uninviting 3 pianists is kind of weird, right? Like getting this gradient right. Whether we have AANNs in the corpus or not, it seems like you get these kinds of distinctions as predicted, where these stubbornly distributive ones are rated less well. And then we can also, I think, excitingly use this to test other hypotheses, like about how the variance of a slot matters. Right? So there's been hypotheses in cognitive science that part of how generalization occurs is by seeing high variability in particular slots. So if you think of the AANN, right, there are certain adjectives that occur a lot in this construction, like mere or whopping occurs a lot. Nouns like days, right, also tend to occur a lot. Measure nouns like days, hours, and so on. So if we split for each of these into a high variability half and a low variability half, so the high variability half will have words like mere and days, and sorry, the low variability half will. The high variability half is going to have things like perspicacious or monkeys. What you see is that if we have our unablated corpus and then compare, right, to having just the open slot, just the high variability slots, or just low variability slots, you actually get a preference on the exact same test set by having the higher variability in there, right? So it's not just having the construction there that helps enable learning. It's seeing the construction in a kind of wide variety of options. Okay. So I think more generally, right, I think this method shows us that we can learn something about the kind of structure of the training data that has to be true for learning to occur. And we can study a really specific linguistic structure in a pretty controlled way. And I'll also say that this can be generalized, right? So we're doing work now thinking about another linguistic construction, which is more frequent, the dative construction. So this is the like gave the x to y. So right, she gave the boy who signed up for class and was excited it, right, is like a bit weird. Probably if you were to like try to communicate that event, you would say she gave it to the boy who signed up for class and was excited. This is part of this general preference in language that kind of shorter elements tend to go earlier in the sentence. And so if you ask models to make judgments comparing, let's say, these two, they typically will prefer, as humans do, the one with the easier element first in an alternation like this. So again, we can kind of run the same playbook and say, what if we go into a corpus? What if we find all the datives? What if we match them, so to get rid of this length preference? Or if we get rid of them altogether? And what we find is these kinds of length preferences seem to show up even if you do these kind of funky manipulations. And again, it seems like it's the case that the dative kind of length preference we're showing here doesn't just exist in isolation. It's part of a much broader kind of linguistic preference to have short things first. And so it's part of a kind of broader network of preferences that are learned, right? Not just some super specific thing. So we're kind of excited about this method in general. So that gets us here to this last question, which is there a path towards an interdisciplinary and theoretically rich linguistics, which language models play a role in? I'm going to say the answer is yes. And so this is something that we talk about in the piece with Richard Futrell I mentioned, right, which is that we give this account that maybe we can think of linguistic theory as what Dennett calls a real pattern, and Ryan Neff has made this point more recently about linguistics in particular, which is this idea that if you imagine alien scientists and they're studying this guy who's like walking by this coffee shop, if the alien scientists had perfect atom-level descriptions of everything that was happening, and you could kind of exactly predict all the behavior of those atoms, they'd kind of be missing something, right? If they didn't have a description of what this was actually happening here, which is like, oh, this person wants some coffee. They think the coffee shop has it, and they're going to walk inside and get coffee, right? The atom-level description is kind of missing something. In the same way, right, it might be the case that if we were to give a kind of very, very low-level description of what's happening in a language model, it's which at some level we know, right? It's predicting next tokens. It's using some complex function optimized via word prediction. You might be missing part of the story, right, if you don't have something like the language model has knowledge of subject-verb agreement. And so for this question of should we expect to find trees or linguistic structures in language models, you could ask something, right, like for something like the key to the cabinets is on the table. You need to know that key agrees with the verb is. We could ask, could we explain this without grammatical subjecthood and hierarchical structure? If we kind of take a Dennett quote and kind of switch it for our purposes. So he said, certainly we can describe all processes of natural selection without appeal to such intentional language. But if we get rid of that part and say language without appeal to linguistic theory, it would come at enormous cost of cumbersomeness, lack of generality, and unwanted detail. We would miss the pattern that was there, the pattern that permits prediction and supports counterfactuals, right? And so this is a kind of account, I think, of the role that linguistic theory could play here. That tells us that these kinds of syntactic structures and representations could be useful in this real patterns way, right? Even if they're not in the brain encoded in some very explicit way. Having said that, right, and so this is an account, a figure in the paper, right, where we kind of give a kind of version of Mars levels from cognitive science, right, that we could give a characterization at a very low level of exactly what's happening in the parameters of the neural network in the same way we could try to do that at the level of neurons. But kind of underlying all of these things is some higher level linguistic structure. And having that kind of structure is going to kind of help us understand things even at the lower level. Right. So having said all that about real patterns, and they're real even if they're not in the brain, there actually might be some reason to think that if the pattern is real, it really has to be in the brain in some way, right? And so I think I missed yesterday's talks, but I think Steve Pansadosi talked about this, that he's got some really interesting work saying that if you have a mental representation that is being computed, right, it's being computed somehow in neurons, and therefore that representation really is real in some meaningful sense. Or the way that Chris Potts recently put it in his LSA keynote that I really liked, where he put up this image of a linguistic structure and then talked about kind of artificial neural representations and biological neural representations and said, it seems to me that I can talk about the feature in either way, symbolic or neural, without any loss of accuracy. Right? And I think that's something that we can really strive for, is trying to get these levels of description to come together. And I think that's one of the things that's most exciting about the current moment in language models and linguistics, is that we have these systems now which seem to be giving these kind of high-level behaviors that we think require these kinds of rich structures. But unlike before, right, we have the ability to kind of probe into them and try to understand what's going on in there and how these pieces link up. OK, so with that, I want to thank my group and collaborators on the work I talked about, and thank all of you. And I'm happy to take some questions.
Time for questions.
Yeah.
Thanks. That was really amazing. I was wondering about the last point about like the idea that really we could just be translating from one language of like dense representations to like the real pattern, which we use more linguistic-y language for. But the I guess the vocabulary of linguistics that we're getting when we talk about like parts of speech. So okay, maybe these dense representations, a more meaningful way to talk about it is like nouns and verbs.
Yep.
But that itself is like conceptually loaded, right? Like we're making assumptions about the grammar when we make those. And so I wonder, like, is there an idea of should we be trying to get those from scratch from models, or like,
Yeah.
Does that make sense?
Yeah, I think that's a really interesting question. And I think there's kind of room for people to have different positions there, right? So like one account you could take is these parts of speech are like really real in some deep, meaningful way, that like there really is nouns and there really are verbs, and they're like discrete categories and they don't bleed together very much, and the language model is kind of noisy, but these are like kind of these perfect discrete representations. I'm actually more inclined towards views that like Martin Haspelmath, who's a linguistic typologist, has pushed, that actually these categories are themselves pretty fuzzy and they're very different across languages, right? So like actually saying what is a grammatical subject, for instance, across languages turns out to be really complicated, because you can have, it's just really complicated. So it's, if you try to do that across languages, it's hard. But a kind of neural network representation might actually say, well, here's exactly, you could have this vector, right, that we're projecting it into in some language is like how grammatical subject looks there. It stands in some relationship to grammatical subject in this other language. They're not exactly the same, but they're related. How related are they? Well, like in exactly the way the network says. And that seems to me really appealing. And that I think to me is like an appealing version of this, which is that the language model might give us new ways to kind of conceptualize like what these categories are and the relationship among things within and across the categories.
Thanks.
Excuse me, it's been a long time since I've been involved with linguistic theory, and I was just wondering, there was a time when natural languages were sought to be modeled, usually with some form of algebra. The Russian group under Kinchin wrote several books on the subject, on algebraic linguistics, and generally came down to things that were so general as to be not very useful, like Noetherian rings. And it was descriptive, not generative, and in fact, not even all that universal, as talking about the universe of natural languages. But I noticed that in your excellent presentation, this trend in linguistic or grammatical explanation was entirely absent. And so I was wondering, what is the status of these types of approaches today?
Yes, I mean, I guess I think of the mainstream of that kind of approach as, generative linguistics, which is, thriving in some parts of linguistics. I think something we say in the recent position paper is that, in a way, it seems like the kind of successor tradition of that on the computational side is more like programming languages, right? Where you have some set of like formal rules in a generative system, and then you get like something like formal like programming languages out of that. On the natural language side, I think there's still a lot of interest in things like trying to characterize the formal complexity of language or trying to characterize something about the generative process. But I think I would say like kind of from language models and just from a lot of psycholinguistics, it seems like there's a lot more statistical learning and learning of constructions and kind of memorization and things at different levels of abstraction that are at least as or more important than whatever kinds of like generative formal structures there are. So it's kind of, you know, in a way it's kind of to what extent do you choose to focus the study of your linguistic data on generating these kind of like high-level formal accounts of language versus focusing more on things like the construction I talked about, which you could give a formal characterization of, but it seems like there's a lot of memorization and a lot of kind of mixing of slots.
Sounds like large language models have displaced a lot of this formalization, and not just in linguistics.
I mean, some of the kind of aspects of theory, but I would say it's not just language. I think that's kind of been a trend of the functional and statistical tradition. The psycholinguistic tradition has kind of pushed back against that trend for a while, I think.
Yeah, really nice talk. I had a couple of questions. First, a very quick one. You know, your AANN, work seemed extremely compelling. So, what's the reaction of Chomsky and linguists to that? What do they say?
So I mean, so I've talked to generative linguists about this. I think so. One reaction is that if it's the case that these networks of constructions are being learned, it might still be the case that there are inductive biases in the transformer model or in something about the way the model is parameterized that's necessary, and that's letting it learn the right kinds of generalizations. Right. So I think, like the AANN work, right? It's true. It's not just you can't just take strings and assume some notion of similarity, right? It seems like it's learning something about the right notion of similarity between strings, and you can say, where does that come from? I think it's fair to say like something about the transformer model is responsible for that. So yeah, one reaction is to say, well, that like maybe universal grammar is in the transformer model, inductive biases are in the model. If that turns out to be kind of a weakened form of universal grammar, I feel like it's fine, but maybe less. I think it's still evidence against what I took to be the stronger claims about universal grammar, that there are things which are really, really language specific, like at the level of, parts of speech and adverbs and structure. And it's just clear the transformer model doesn't have that built into it. So that can't be the level of universal grammar in the model.
So my second question was sort of the converse of, the flip side of that, which was, if you were to say, look, if you take this structure, this hierarchical structure, and so on, have people thought about, ways of combining that with the statistical approach? Put the two together as maybe a more succinct way of learning and so on.
Yeah. I mean, there's been a bunch of interesting work of like trying to put hierarchical structure or trees in models. Like Tom McCoy had a paper like several years ago now about do language models grow on trees or something like that. But can you do better by putting syntactic trees in? And the answer seems to be like, yeah, it helps somewhat, but like language models also seem to do quite well without those things like explicitly built in. I'd say another thing that occurs to me about like what a generative linguist reaction might be is that certain schools of linguistics are very attached to the idea that what language really is linguistic competence, and so like knowing with 100% perfect accuracy this is in the grammar and this isn't, and like this kind of language model approach, like it kind of isn't well set up to do that, right? It's going to put a probability in every string, and there's going to be some gradient, right? And it's kind of weird to ask the question, what is the like grammatical competence of the model as opposed to like its performance? I'm kind of fine with that, because I think I think you could reasonably say that the interesting thing about what people do with language is that like we use it successfully to communicate, and having like a good statistical approximation to some system seems quite good for that. Yeah, I think there's interesting questions there.
Follow up to the question about, or to your statements about inductive biases in the transformer and the discussion you were just having. How robust is the LLM judgment to things like prompting? And the sort of thing I have in mind is I imagine you could prompt the model to be like a prescriptivist versus a descriptivist, which is not the thing you were getting at there. But like, I'm wondering, could you cause it to flip results with sufficient prompts? And maybe that's not interesting if you just tell it to do the other thing, but maybe, yes. So just how robust is it?
Yeah, so I actually skipped over this. So I think prompting and the relationship between prompting and grammaticality judgments is super interesting. So Jen Hu had this work showing that prompting, you could kind of underestimate how good models are at grammatical competence, because to get a prompt right, you have to not only like know the grammatical judgment, you have to like understand the prompt, which is actually probably harder. So we have this project now with an undergrad, Sion Song, and so these are a bunch of models that we're prompting here, which you can't read, but they go in like order of size. And then this, for each model, we get its judgment on a grammaticality pair from the prompts, and then we also get its log probabilities judgments for the same grammatical pair. And we do that within model, and then we do it across all the other models in the set. And so the black dots here are the within a model comparisons. And then the y-axis is the rank. And so like if models were kind of perfectly introspecting, when you like prompted them, you know, what do you think is more likely? And they actually were able to tell you which of the two versions they think is more likely, the grammatical or the ungrammatical one, you'd expect the black dots to all like fall along this line here. They'd all be like the number one thing. And actually they don't at all. And that was kind of interesting and surprising to us. So it seems like the knowledge you get when you ask a model questions about grammaticality might be like a quite different body of knowledge than the knowledge the model uses to like actually generate strings. And like also ask the way the prompt is phrased matters. So it's there's like some relationship between them maybe, but it's not basically you can use another model to better predict a different model's probabilities than the same model, and that's kind of weird and surprising.
Hi, thank you for your talk.
Yeah.
I have a question kind of back to this point about the relationship between like a generative syntactic approach and like specifically with respect to like the AANN project. I wonder if an extension like from that project for kind of more generative approaches is like, okay, generative approaches oftentimes talk about relationships between structures by saying, okay, these two structures involve the same sort of like grammatical process, like making a relative clause and forming a WH question. These are what a generative syntactician calls like a bar movement. And then you can kind of use, these proposals as ways to generate these like sets of things to remove, and then you can see, where performance drops and kind of as a verification process for those sorts of hypotheses. But I'm wondering, like extending that line of thinking a little more, like a generative syntactician's response to, let's say, okay, you remove relative clauses, but you see performance on WH questions doesn't actually drop. And then you conclude, okay, maybe they're actually not related in the same way. And then the generative syntactician says, well, maybe these models are not learning in the same way that humans are. Yep. And what kind of, like where is the recourse for the LLMs in this?
Yeah, I think that's like exactly the direction things could go in, and not just using these kind of pre-training paradigms, but also, like as Chris Potts talked about in this LSA keynote I mentioned, like he uses causal gem to study this pip construction, right? And you can like potentially extend that and ask like, exactly what you're saying. Like if there's hypothesized to be some related structure, can you see that across like things that look different in a surface way but are the same? I think that's a really interesting question. Like if it turns out that you don't see the hypothesized effects, like does that count as evidence against the hypothesis, or does it just mean like the model's doing something different than what people are doing? I I think we can be more confident about these kinds of hypotheses for like kind of giving a formal description of the language. I think we don't have like a ton of great evidence in people that things like these like very abstract kinds of grammatical relationships are like neurally represented in the same way. There's like maybe there's some psycholinguistic evidence here and there, but I think that's like a pretty open question. So I would not take like a strong stance that if the model turns out to be having a different representation for this kind of longest dependency versus like a WH dependency versus another kind of filler gap dependency, that shows it's unhuman-like. Like maybe, but I think I'd not be super inclined to dive straight to that conclusion, but would kind of be exactly interested in then trying to figure out how to test whether what the model is doing like does give us a hypothesis for what people are doing.
I just feel like the second question. But following up on that and bringing another point together, like, so as you mentioned, there's a difference between like prompting a model, hey, is this grammatical versus looking at the underlying probabilities. The kind of thing that you guys were just talking about, where we're trying to like establish the validity of these comparisons between like the model learning process and human learning processes. When we get baselines from humans, like in any of these plots when we have human baselines, we're asking humans to make meta-linguistic judgments. Because when we ask a human for the grammaticality judgment, we're saying, here's a sentence, do you think it's grammatical? Whereas with models, we get better results when we look at like the underlying probabilities. Is that mismatch a problem? Is there like, I don't know if there's even a way to get underlying grammatical behavior from humans that's not like this like prompting style meta judgment.
Yeah. This is like a big debate in psycholinguistics, or has been for a while. Is like how valid are kind of acceptability judgments for giving you like major linguistic insights? Like clearly, right, you get something out of that by asking people, is this grammatical or not? But there are also methods in psycholinguistics like self-paced reading or eye tracking, where you can kind of try to tap in to people's kind of less explicitly conscious metalinguistic behavior and look at actual processing. And these things, I don't know, kind of as you right, these things align reasonably well in some ways, right? Like what people will say and what kinds of behaviors you see in like reading time studies, but will come apart in other ways. So yeah, it's like there's super interesting work linking up like model behavior with human reading time behavior, right? So like a key insight from reading time is that complexity and difficulty and surprisal like slows people down, and so you could ask whether surprisal and complexity measures from models predict reading time. So yeah, that's been super interesting. Yep.
I'm still trying to wrap my head about these AANN things. Do you think someone in the 18th or 19th century would have considered those grammatical? And if not, so just by people using it, suddenly a new grammar rule comes into being, and how would a generative model even try to explain that? Or so other than just describe it and have statistics about it?
Yeah, so actually, that's a good question, the history of it. I think they were around in the 18th and 19th century. I've been told that German is quite related to English, but German does not have this AANN construction, is what I've been told. And so it'd be an interesting question, like whether, you could hypothesize that because it exists in English, it like could exist in German, right? Like you could also imagine it not existing in English, right? So a lot of these interesting things about these constructions are, like you say, they like pop into existence, and it's not obvious they had to be that way. But yeah, I think this is something that language models give us a kind of nice account of, like how does something new, like how does language change, right, happen? Because right, they have a pretty nice mechanism where if you like start putting something in the data, like it's going to learn it. But yeah, I think this was one of the limitations always with attempts like hand engineer grammars. It's like harder to think about how to deal with language change, or like an approach where something is either in or it's out. I think it's harder to think about how to
Probably could trace on old material and see what happens. Right?
Yeah. Hi, I'm just wondering, like, so you made a pretty compelling and optimistic case how we can learn about syntax and like theories of syntax and LLMs and like the symbiosis. I'm wondering if you're as optimistic also for like other fields like semantic theories of semantics or pragmatics, or if it's a bit more messy in those fields, I guess.
Yeah, I mean, also optimistic about semantics and pragmatics. I think, in a way, the language model kind of like invites you to blur all of those things together and kind of, right, so semantic and pragmatic and like, yeah, no, it's like becomes a trickier question to figure out how, when you're studying something that a model is doing, is it syntactic or semantic or pragmatic behavior you're studying is like kind of a harder question in some way. Yeah. I mean, I'm also optimistic that like sociolinguists who are like well positioned to think about forms of dialogue and like language contact and things, right? Like as like people are talking a lot to language models now in a way that wasn't true a few years ago. They're producing a lot of text, which is ending up on the internet, and so like I think there's cool opportunities for sociolinguists to think about both like what that process is like and then how it's going to kind of affect our speech communities.
Cool.
Yeah. Okay, thanks. Cool. I think we have a 15-minute break now.